Look up at the night sky for just a moment. Those tiny points of light seem still, yet every one of them is racing through the darkness at impossible speed. Planets, worlds like ours, glide around their stars in perfect silence, as if tied by invisible strings. But what holds them there? Why don't they simply fall into the sun, or drift away into the endless void? Tonight, we're going to follow that question into the heart of the cosmos, where motion, gravity, and time weave together in a cosmic dance. This isn't a quick lesson or a lecture. This is a quiet journey, a soft unfolding of one of nature's most elegant secrets. We'll move slowly, as planets do, tracing their paths with our minds, until the mystery feels as natural as breathing. Before we set off, take a moment to let your shoulders relax. Feel the weight of the day slipping away. And if you enjoy falling asleep beneath the stars with me, gently tap like, subscribe to The Thoughtful Night, and tell me in the comments where in the world you're watching from, because every point on Earth is part of this cosmic motion. 2. Now, close your eyes if you like, or just dim the lights. Imagine yourself rising above the roof of your home, higher than the trees, higher than the clouds. The city lights fall away beneath you. The curve of Earth appears, blue and quiet, moving ever so steadily around its star. From up here, everything looks still. But nothing in space is ever still. Planets spin, stars orbit, galaxies drift like islands on a cosmic sea. And our question begins here in this silence. How do planets stay in orbit? We'll start with the way it feels from Earth, as if the heavens are unchanging, and follow the trail through the minds of those who first dared to ask why. We'll meet ancient astronomers who imagined crystal spheres turning in perfect harmony, a young thinker named Newton who realized that motion is forever, and later Einstein who showed us that gravity is not a pull at all, but the bending of space and time itself. By the time our hour is done, you'll see why the planets do not fall. They are not held up by ropes or magic. They are falling constantly, and yet they never land. So take a deep breath, let go of everything you've been holding on to, and come with me now, as we leave the ground, drift past the clouds, and slip into the quiet dark where planets move in endless circles, steady and sure. On certain nights, when the air is calm and the world grows quiet, you may step outside and feel as though time itself has stopped. The stars above you seem perfectly still, like tiny lanterns pinned to a dark velvet dome. The moon glows softly, serene and unhurried. It feels as though you are standing on something solid, something utterly unmoving, gazing at a sky that never changes. But this stillness is an illusion, a trick played on us by the vastness of space and the steadiness of our motion. Even as you listen to these words, the ground beneath your feet is spinning eastward at nearly 1,000 miles an hour. And that's just the beginning. Our entire planet is hurtling around the sun at over 60,000 miles per hour. A journey so smooth you never feel a single bump. How can something move so quickly and yet feel so calm? The answer lies in the nature of motion itself. In space, there is no wind to whistle past your ears, no ground rushing beneath you. Once an object begins moving, it glides effortlessly, needing no push to keep it going. Motion is the natural state of things in the silent void. For most of human history, though, this was far from obvious. People looked up at the stars and saw them standing still while Earth seemed solid beneath their feet. Who would have guessed that it's the other way around, that we are the ones who move, and the stars are simply too far away to betray their own journeys? If you could watch Earth from far above, from the vantage point of space itself, you would see our planet spinning like a jewel on a black velvet cloth, completing one full turn each day. You would see it circling the sun, tracing a graceful path that repeats every year without fail. And yet, from our human perspective, standing still on the surface, this motion is invisible. Feels like nothing at all. This leads to a deeper mystery, one that puzzled thinkers for centuries. If the Earth and the planets are moving, what keeps them moving? Why don't they stop? Why don't they fly away into emptiness or plunge straight into the sun? To begin answering that, we must understand a simple but profound truth. Motion in space is free. Here on Earth, if you slide a cup across a table, friction slows it down. If you toss a ball into the air, gravity pulls it back. Our daily experience teaches us that moving things naturally come to rest. But out in the vastness of the cosmos, there is nothing to slow them. Planet does not need a constant push. Once it is moving, it will continue along its path unless something like gravity changes its direction. Think of a ship drifting on a perfectly still sea, with no wind and no waves. If it were set moving, it would glide on and on without ever stopping. Space is even quieter than that imaginary sea. It offers no resistance at all. And so Earth races around the sun not because something is pushing it forward, but because it was set in motion long ago, in the earliest days of the solar system, when swirling clouds of gas and dust collapsed into planets and stars. That ancient spin never faded away. But if motion alone kept us going, we'd travel forever in a straight line, leaving the sun far behind. Something else must be at work, something that keeps bending our path, drawing us into a graceful curve. That something is gravity, the silent sculptor of the heavens, gently steering the planets as they speed through space. You don't feel this motion because you and everything around you, oceans, mountains, cities, clouds, are moving together. There is no sense of acceleration, no sudden lurch. Like a passenger on a smooth train, you only know you're moving when you glance out the window and see the scenery slide past. But in space, the scenery is so far away that it hardly seems to move at all. The night sky hides its motion well. The constellations appear fixed, the planets wander slowly, the moon glides from one horizon to the other. Yet underneath this calm surface, an immense dance is underway. A dance so steady and precise it has lasted for billions of years. As we gaze upward, we are not standing still on a quiet Earth. We are riding a world in motion, a world circling its star at tremendous speed, guided by unseen forces. And the question, what keeps us there, steady and secure, has led humanity on one of its greatest journeys of discovery. In the chapters ahead, we will follow that question from ancient stargazers to modern scientists. We will see how thinkers first imagined crystal spheres turning in harmony, then how Isaac Newton revealed a deeper truth about gravity and motion, and how Einstein later transformed our understanding again. For now, let the thought settle in your mind. You are not standing still. You never have been. Every moment of your life, you have been carried through space on a planet that glides effortlessly, guided by forces both invisible and eternal. The sky may look still, but it is alive with motion. And to understand why, we must first step back in time, to an age when people believed Earth itself could never move. Long before telescopes, long before satellites, long before anyone imagined a blue planet circling the sun, people looked up and wondered. Night after night, the same stars appeared in the same patterns. They rose in the east, glided overhead, and sank into the west, always returning in their familiar places as if pinned to a celestial ceiling. But among these steady lights were wanderers, tiny points of light that refused to stay put. They crept forward against the backdrop of stars, then paused, even seemed to drift backward before resuming their path. The Greeks called them planets, wanderers. These were the planets: Mercury, Venus, Mars, Jupiter, Saturn. Their erratic paths puzzled the greatest minds of the ancient world. To explain this mystery, thinkers like Aristotle and Ptolemy imagined elaborate models of the heavens. They pictured Earth as fixed at the center of everything, unmoving and eternal. Around it, they envisioned crystal spheres, perfect and unchanging, carrying the sun, moon, planets, and stars like jewels set in glass. The spheres turned with steady majesty, guided by divine hands, producing a cosmos of order and harmony. It was a beautiful idea, comforting even because it placed humanity at the center of creation. But there was a problem. Those wandering planets refused to behave. Sometimes they shone brightly, sometimes dimly. Sometimes they moved forward, then backward, as though hesitating. To explain this, Ptolemy devised an intricate system of circles upon circles, tiny wheels turning on larger wheels, each spinning at just the right speed to match the strange motions seen in the sky. This geocentric model worked well enough for many centuries. It predicted the paths of the planets, allowing scholars to chart eclipses and guide sailors. Yet something about it felt strained, almost artificial, a mechanical contraption, endlessly adjusted to fit the facts rather than a simple truth revealed. Then came Copernicus, a quiet man with a daring thought. What if Earth was not the still center of everything? What if the planets, including our own, all circled the sun? Suddenly, the puzzling loops and backward steps of the planets made sense. They weren't actually reversing course, it only looked that way from our moving vantage point. Like ships passing on a river, their relative speeds created illusions in the night sky. Still, this was no small shift of perspective. To accept it was to accept that Earth itself was in motion, hurtling through space, an idea that felt absurd to many. If our planet were truly moving, wouldn't we feel it? Wouldn't birds be left behind, or clouds torn away by the rushing air? The senses seemed to argue against it. And yet Copernicus persisted. He worked quietly for decades, polishing his model until it could explain the wandering planets with elegant simplicity. He delayed publication of his great book until the end of his life, knowing it would challenge deep-rooted beliefs. When it finally appeared in 1543, it whispered a revolutionary truth. The sun is the anchor, and we are travelers. But even this bold new picture left questions unanswered. Why should planets stay in their paths? What kept Earth from falling straight into the sun, or from flying off into the void? Copernicus had rearranged the cosmic map, but he had not revealed the force that drew it all together. In the generations that followed, astronomers like Tycho Brahe charted the skies with exquisite precision. His assistant, Johannes Kepler, uncovered hidden patterns. The planets do not move in perfect circles, but in graceful ellipses, sweeping faster when they draw near the sun and slower when they drift farther away. The heavens, it turned out, were not the perfect geometric paradise Aristotle had imagined. They were something even more wondrous, obeying laws written deep into nature itself. Yet still the deeper question remained: what causes this motion? What invisible hand holds the planets in their paths, guiding them through their endless journeys? The stage was set for a new kind of answer, not one built from crystal spheres or divine gears, but from the understanding of motion itself. When a young thinker named Isaac Newton began to wonder why apples fall to the ground and why the moon stays in the sky, he saw something no one had seen before. These were not separate mysteries, but one and the same. The ancient puzzle of the wandering planets was about to be solved, not by adding more circles or spheres, but by uncovering a universal truth. And to reach it, we must think about falling in a new way, not as a thing that ends when you hit the ground, but as something that could go on forever if the ground never arrived. Imagine standing on the edge of a high cliff, holding a stone in your hand. If you let it go, it falls to the ground below. If you throw it outward, it arcs through the air before gravity pulls it down. The harder you throw, the farther it travels before landing, but always, eventually, it hits the earth. Now picture something extraordinary. What if you could throw that stone so fast that, by the time it falls, the ground curves away beneath it? What if it kept missing the earth, falling forever but never hitting? That, in essence, is what it means to be in orbit. Isaac Newton imagined just this. In his mind's eye, he stood on a high mountain, so high that the air would not slow the stone's flight. He imagined firing a cannonball straight out, faster and faster. At a low speed, it would fall nearby. At a higher speed, it would land farther away. And at a certain speed, it would fall at exactly the same rate that the earth curved beneath it. The result: the cannonball would never land. It would circle the planet endlessly, always falling, always missing. This was Newton's great leap of understanding. The moon is not held up by any invisible pillar. It is not glued to the heavens or carried on a crystal sphere. It is falling around the earth in just the same way his imaginary cannonball would. Its forward motion keeps it from crashing down. Gravity keeps it from flying away. The same is true of Earth as it circles the sun. Our planet is in a perpetual state of freefall. We are always being pulled toward our star, but our motion carries us sideways so swiftly that we never get any closer. Instead of plunging straight inward, we trace a graceful curve around the sun, again and again, year after year. It is a strange idea at first. When we think of falling, we imagine something that ends, a leaf drifting to the ground, a raindrop striking the earth. But in the vast emptiness of space, falling can continue forever, because there is nothing in the way to stop it. Picture the Earth's path as a smooth ribbon wrapping around the sun. There are no jerks, no sudden changes, just a perfect balance of two things: motion and gravity. Motion tries to carry Earth in a straight line, out into the darkness. Gravity tries to pull it inward. Together they create a cosmic compromise, the endless glide of orbit. This insight was revolutionary because it united the heavens and the Earth. For thousands of years, people believed the laws governing the stars must be different from the laws that govern an apple falling from a tree. Newton showed they are one and the same. The same force that pulls a stone to the ground keeps the moon in the sky. The same mathematics that describes a ball rolling down a hill explains the paths of planets and comets. And so the old cosmic puzzle, why planets wander, why they stay in their paths, was solved not with wheels upon wheels or invisible spheres, but with something far simpler and deeper: gravity and motion intertwined. This also explained why orbits are stable. Once a planet has the right speed, it keeps that speed. In the vacuum of space, there is no friction to slow it down, no air to push against. A world that begins its journey around a star will keep circling unless disturbed by some outside force. That's why the planets have followed their paths for billions of years, almost unchanged. Let your mind drift for a moment to what this feels like. You are sitting on a planet spinning on its axis, orbiting the sun, which itself orbits the center of the Milky Way. Yet you feel none of it. You feel steady, grounded, at rest. But really, you are falling through space along with Earth, falling yet never arriving. There is a peacefulness to this thought. Gravity is not violent or chaotic here. It is gentle, steady, reliable. It holds the planets in their courses like beads sliding on a string, endlessly circling, endlessly balanced. When Newton published his work, the world changed. The heavens were no longer the realm of mysteries separate from Earth. They were part of the same universe, ruled by the same elegant laws. Suddenly, the dance of the planets could be understood with clarity, calculated with precision, even predicted far into the future. But Newton's story does not end here. He gave us the law of gravity. Every object attracts every other with a force that depends on their masses and the distance between them. This law explained not just why planets stay in orbit, but why their paths sometimes shift slightly under the pull of their neighbors, why comets sweep in close and then swing far away, why tides rise and fall with the moon's passage. The sky was no longer a place of divine machinery. It was a place of natural motion, as beautiful and understandable as the fall of an apple. In the next step of our journey, we will look more closely at this invisible force, this thread of attraction that binds planets to stars and moons to planets. What exactly is gravity, and how does it reach across the void to hold the solar system together? Across the dark canvas of space, nothing touches, yet everything is connected. The planets do not hold hands with the sun. The moon does not grip the earth with invisible fingers. And yet, they stay together, bound by something that cannot be seen or felt directly, yet shapes the entire universe. Isaac Newton gave this connection a name: gravity. He saw it not as a special power of Earth alone, but as a universal thread weaving all things together. Every grain of sand pulls on every other grain. Every planet tugs on every other planet. Even the stars, separated by light years, whisper to each other through this force. Think of gravity as the softest of threads. It does not yank or jerk. It does not snap or break. It is patient, steady, always reaching across the void. The sun's gravity pulls on Earth with just the right strength to hold it close but not too close. In return, Earth's gravity pulls back on the sun, though the sun is so massive that it barely stirs in response. Newton described this attraction with simple elegance. Every object in the universe attracts every other object with a force proportional to their masses and inversely proportional to the square of the distance between them. In other words, heavier objects pull more strongly, and objects far apart feel a weaker pull. This may sound technical, but its meaning is breathtaking. It says there is no place in the cosmos untouched by gravity. Whether it is a falling apple, a circling moon, or a planet gliding around a star, all are following the same rule. There is no separate physics for the heavens. There is just one law written everywhere. To feel its poetry, picture the solar system as a great mobile hanging in space. Each world, each moon, each comet is a weight suspended by invisible threads. They sway and circle not because someone is holding them, but because gravity itself shapes the way they move. Why do planets travel in curves instead of flying straight? Because gravity is always nudging them inward. Imagine a runner on a circular track. If the runner could somehow throw away friction and momentum, they would shoot off into a straight line. But if a thin rope tethered them to the center of the track, it would keep pulling them inward, curving their path. In orbit, gravity is that tether, no rope, no anchor, just an endless inward pull balanced by forward motion. The beauty of Newton's law is that it works everywhere. It explains why the moon circles Earth, why Jupiter holds more than 70 moons of its own, why Saturn's rings stay in their elegant bands, and why Earth's oceans rise and fall with the pull of the moon. Gravity reaches across millions of miles without wires, without wind, without anything at all, just the silent geometry of nature. And it does something even more profound. Because every object attracts every other, gravity knits the universe into a single whole. You are connected to the ground because Earth's gravity holds you. But you are also connected in the tiniest possible way to every planet, every star, every galaxy. Their pull is unimaginably faint, but it is there, a universal thread binding all things. This thread does not fray with time. The Earth has circled the Sun for more than 4 billion years, and it will continue to do so for billions more, unless some great disturbance interrupts its path. Planets are faithful dancers in this cosmic ballet because gravity never forgets its step. Let your thoughts linger on this quiet certainty. The Sun's gravity is always there, gentle yet unyielding. It keeps Earth from straying too far, yet allows it to roam wide enough for life to thrive. This balance of attraction and motion is why you can count on the seasons, why the stars rise where you expect them, why the moon keeps its steady rhythm in the sky. Newton's discovery changed more than astronomy. It changed how we see ourselves. No longer were we at the center of crystal spheres. We were travelers bound by the same laws as the wandering planets. The universe was not a clock wound by gods but a web of natural order, a harmony that could be understood. Yet even Newton did not know everything. He could describe gravity with unmatched precision, but he could not explain why it worked. What is this thread? How does it reach through empty space? He accepted it as a fact, a law of nature, even as he admitted he did not know its ultimate cause. Centuries later, Albert Einstein would look at this mystery in a new way, and discover that gravity is not really a force pulling at all, but the very shape of space and time curving under the weight of matter. But that revelation comes later in our journey. For now, rest in the picture Newton gave us. Planets tracing curves around the sun, moons gliding around planets, every motion guided by a universal attraction. A soft thread holds the cosmos together. It does not loosen. It does not break. In the next chapter, we will see how this invisible pull must be matched by motion itself. Why planets must move at just the right speed to keep their balance in orbit, neither falling inward nor flying away. Picture yourself again, floating high above a planet, far beyond the whispers of air, where silence feels alive. There is no up, no down, only the curve of a horizon and the quiet hum of motion. And yet, everything here is moving, not in frantic jerks, but with a grace that feels rehearsed. The secret to orbit is not just gravity, but speed, a perfect, subtle balance. Fast enough to fall around a planet, but not so fast you escape its pull. This is the hidden dance every moon, every satellite, every wandering world must master. Imagine tossing a stone. On Earth, it arcs through the air, falls and strikes the ground. Throw it harder and it flies farther. Harder still, and the arc grows so wide that, if Earth were not in the way, the stone would just keep falling but miss the ground every time. That, in its simplest form, is orbit. Falling forever, but never landing. This speed is called orbital velocity, and it is not guessed at. It is written into the fabric of physics. A satellite just a few hundred kilometers above Earth must travel about 7.8 kilometers per second. That's roughly 28,000 kilometers per hour. A pace so quick that it circles the entire Earth in about 90 minutes. Go any slower and gravity drags you down. Any faster, and you begin to break free, rising to higher orbits or even leaving the planet's embrace altogether. You can almost feel the tension, a cosmic tug-of-war where no one ever wins. Gravity pulls inward, speed flings outward, and the result is neither crash nor escape, but harmony. Every orbit is a compromise written in motion. This balance isn't just for human-made satellites. The moon itself glides around Earth at just the right pace, about 1 kilometer per second. Slower, and it would spiral downward over millions of years. Faster, and it would drift away even more quickly than it already does. Yes, even now, the moon is inching farther from us each year, slipping gently outward because of subtle energy exchanges with Earth's tides. On a grander scale, planets follow the same rule. Earth circles the Sun at an astonishing 30 kilometers per second. Mercury, closer in, must race at 47 kilometers per second to avoid plunging into the Sun. Neptune, far out at the edge, drifts lazily at 5 kilometers per second. Slow, but still fast enough to keep from being lost to the dark. It's not just speed that matters, but direction. The motion must curve just so, aimed not straight at the planet or straight away, but sideways at the perfect angle to keep falling without ever colliding. Picture a skilled skateboarder leaning through a turn, held in place not by walls but by momentum. That's how worlds and moons hold their lines through the void. Sometimes, when this balance is disturbed, the universe writes drama across the sky. A comet swinging near Jupiter may be sped up or slowed down by its massive gravity, altering its path forever. A spacecraft nudging its thrusters for a second or two can shift into a higher orbit or fall back toward Earth. Even entire stars can be flung from galaxies if they pick up too much speed from a gravitational encounter. But when the balance is just right, the result is serene. You could ride alongside the International Space Station and feel the Earth sweeping past below, its clouds and continents scrolling by like living maps. Yet inside the station, there is no sense of rushing. Astronauts drift in weightlessness, coffee floating like beads of amber in the air, because they and their ship are falling at the same pace together. Speed creates stillness. Perhaps you've felt this in a gentler way. Think of riding a bicycle fast enough to stay upright, where motion itself keeps you steady. Slow too much and you wobble. Glide at just the right pace, and the path feels effortless. Orbit is like that, except instead of wheels on pavement, the traveler balances on the invisible curve of spacetime itself. And this isn't a fragile equilibrium. For billions of years, Earth has traced its same elliptical path around the Sun, neither crashing inward nor drifting away. The planets are not teetering on the edge of disaster, but locked in rhythms so stable they can be predicted for millions of years to come. That is the true wonder, motion that feels eternal. Speed and gravity do not fight. They cooperate. Without gravity, objects would fly endlessly straight, unbound and alone. Without speed, they would collapse inward, swallowed by what they orbit. But together, they weave a path around the emptiness, an eternal compromise that becomes something beautiful. An orbit, smooth and unbroken. And so, as you imagine yourself gliding alongside a planet, see this balance everywhere. In the moon's steady pace, in the drifting of distant satellites, even in the great arcs of stars around the centers of galaxies. The cosmos holds its shape not because things are still, but because everything moves in tune. You are part of that motion, too. Even as you rest, the ground beneath you spins with the Earth flies around the Sun drifts around the galaxy. Motion is the quiet heartbeat of the universe. And now, with this speed and balance in mind, let us follow the thread of history again, to see how humanity learned not just to feel this truth, but to prove it. The night sky has always seemed so orderly. For centuries, people believed the heavens moved in perfect circles, neat, flawless, divine. After all, what shape could be more perfect than a circle? But the universe has its own ideas of beauty, and sometimes perfection is not symmetry, but balance. In the early 1600s, a quiet man named Johannes Kepler studied the motions of the planets, using the meticulous observations of Tycho Brahe. He expected to find circles, everyone did, but instead, he found something more subtle. The planets traced paths that were slightly stretched, like ovals, like the shape of a softly plucked string frozen in mid-vibration. These paths are called ellipses. In this invisible geometry, the sun does not sit at the exact center of the dance. It is offset, like a dancer who stands just outside the spotlight yet still commands the stage. As each planet sweeps around, it comes nearer and then drifts farther, moving in a cosmic rhythm that never repeats exactly, yet never falters. Kepler's first law whispered this truth. Planets move in ellipses with the sun at one focus. His second law added something even more remarkable. Planets change their speed as they travel. When closer to the sun, they hurry, pulled by its warmth and gravity, as if eager to linger near its fire. When farther away, they slow, reluctant to let go of the faint embrace. It is a cosmic heartbeat, a breathing of worlds. Imagine watching Earth itself from far above, not as a static marble hanging in blackness, but as a runner on a winding track, its pace quickening and easing, month by month, season by season. The ground beneath your feet feels steady, yet the planet is constantly adjusting, constantly tracing this invisible oval. Kepler did not know why this was true. He only knew that the heavens followed this hidden order, this invisible geometry written into space itself. It was a geometry of motion, of balance, of a silent accord between speed and distance. Later, Newton would reveal the force behind it, gravity, the universal pull. But even without knowing why, Kepler could describe exactly how. Think of an ice skater spinning with arms stretched wide, then pulling them close. As the arms draw in, the spin quickens. As they reach out again, it slows. So too with planets. Nearer to the sun, they rush. Farther out, they glide. This is not chaos, but choreography. An elegant dance inscribed on the canvas of the cosmos. Picture the solar system now. Mercury darting quick and nervous. Venus steady and smooth. Earth carrying us gently along. Mars trailing in a slower arc. And beyond them the giants, Jupiter and Saturn, turning with regal grace. All are following these elliptical paths, every world bowing to the same unseen mathematics, every orbit a page from Kepler's book. What Kepler discovered was not only a description of motion, but a glimpse of harmony. He called his third law the harmonic law, believing the planets were playing a kind of music, not music we could hear, but music we could understand through number and pattern. The invisible geometry was not silent after all. It was singing to anyone who knew how to listen. And so the perfect circles vanished, replaced by something far richer. The heavens were not mechanical gears grinding predictably, but living patterns, breathing curves, subtle as a painter's brushstroke. The sun, slightly off-center in every orbit, seemed almost alive, not fixed and rigid, but like a heart around which everything pulses. As you drift deeper into the story, imagine tracing these ellipses yourself, gliding through space in absolute quiet. No engine, no effort, just falling endlessly around the sun, never touching it, never breaking free. You are part of this geometry even now, carried along on Earth's tilted oval, feeling only the calm illusion of stillness. In Kepler's time, this discovery was revolutionary. It overturned ancient ideas of perfection and replaced them with something more real, and perhaps more beautiful. Nature does not need flawless circles to be divine. Its ovals and off-center dances are more alive, more human somehow, imperfect only to our eyes, not to the universe. As the chapter closes, remember this: planets do not move by chance. They follow an invisible script, a geometry older than history, written not with ink, but with motion itself. And this script does not merely keep the planets in place. It tells us something about how the universe thinks, how it balances motion with gravity, speed with distance, chaos with order. Let that thought settle, soft as starlight. Every night, as you sleep, Earth keeps its appointment on that ancient oval path, circling the sun with unerring grace, guided by a geometry you cannot see but can feel. Steady, faithful, eternal. Close your eyes and imagine space as a vast, silent concert hall. No air carries sound, yet there is a rhythm, a harmony. a hidden score written not in notes but in motion. Each planet is an instrument. Each orbit is a melody line. Together, they create a music so deep and slow that human ears could never hear it, but the mind can feel it. Look first at Jupiter, the giant conductor of our solar system. Its immense gravity does more than keep its own moons in line. It shapes the paths of asteroids, stabilizes or disrupts orbits, and sends long, slow pulses through the cosmic symphony. Jupiter's moons, Io, Europa, and Ganymede, follow one another in a perfect pattern. Their orbits lock together like dancers in step. Every time Ganymede circles once, Europa circles twice, Io 4 times. Their rhythm is no accident. It is gravity's music, a resonance that repeats, measure by measure, never missing a beat. Farther out, Saturn's rings hum with countless icy particles, each one a tiny worldlet tracing its own path. Some are shepherded by moons that act as guardians, plucking the strings of gravity, keeping the rings sharp and clean. If you could translate their motion into sound, it would not be random noise. It would be a shimmering chord, a harmony sustained over billions of years. Gravity, despite its invisible hand, writes order into what might otherwise seem chaos. Think of the planets circling the sun at different speeds, different distances, never colliding. How do they avoid a cosmic pileup? The answer is that each orbit fits into a kind of pattern, like separate notes that never clash. Their mutual pulls nudge and sway them, but rarely do they strike a discord. And when a near miss does occur, when an asteroid passes close to a planet, when two worlds tug a little harder at each other, gravity doesn't just threaten destruction. It often reshapes the melody. A wandering object can be captured, becoming a new moon, or it can be gently deflected, sent drifting down another path, joining a new harmony. Even disruptions are part of the larger song. Think of this grand orchestration across time. Kepler first heard it as mathematics, planets moving faster when near the sun, slower when far away, all in precise proportion. Newton translated that rhythm into force and mass, a cosmic heartbeat of attraction. But if you listen as a poet, not just as a scientist, you sense something deeper. The planets are not just obeying equations. They are participating in an endless performance, one that began long before humanity and will continue long after. Consider how fragile yet reliable it all is. Mercury races close to the sun, swift and hot, while Neptune drifts cold and slow at the edge of darkness. Yet both keep their appointed pace. Nothing rushes ahead too far. Nothing lags too much. And in that balance lies our own existence, the steady orbit of Earth keeping us at just the right distance for oceans to flow and forests to grow. But gravity's music is not limited to planets. Stars in galaxies, galaxies in clusters, even these colossal structures dance. They swirl and weave, attracted to each other by the same fundamental note that keeps Earth tethered to the sun. Astronomers have found vast resonances, where entire systems seem to beat together, vast chords played on an unimaginable scale. Picture it now. The solar system as a cosmic mobile, every planet suspended by an invisible string. As each world swings around the sun, it creates a slow, majestic vibration. The strings are never still. They pluck one another, whispering across millions of miles. And yet the whole mobile stays balanced, swaying but never falling. There's comfort in this deep order. While human lives rush with urgency, deadlines, alarms, ticking clocks, the music of orbits reminds us of a different pace. Planet does not hurry. It does not fret over being late. It follows its path with calm precision, guided by an unseen hand. If you could stand outside time and listen, you would hear Earth's year as a single sustained note, Mars' slower beat as a low hum, and Jupiter's deep, patient tone as a bass string holding the harmony. Together, they play the music of gravity, a lullaby for the universe. And as you let this music settle in your thoughts, remember this: we are part of it. Not separate listeners in a cosmic theater, but instruments ourselves. Every human, every city, every ocean rides on this spinning, circling world, which in turn moves to the rhythm of a far greater song. Now, let us follow this music as it changes key. For Newton heard only part of the melody. A powerful theme, yes, but not the whole. Another composer arrived centuries later, adding a richer harmony, bending the staff lines of space itself. To understand how planets truly stay in orbit, we must leave the old symphony hall and step onto a stranger stage. One where space is curved, and time itself keeps the beat. Close your eyes for a moment and imagine space not as emptiness, but as a deep, invisible fabric, smooth, silent, stretching in all directions. Imagine stars and planets not floating in this void, but resting gently upon this fabric, pressing down ever so slightly, like marbles on a soft sheet. Now imagine that the sheet is not flat but can dip, stretch, and curve under their weight. This is where Isaac Newton steps aside, and Albert Einstein takes the stage. Newton had shown that gravity pulls with a predictable force, but Einstein whispered something different. Gravity isn't really a force at all. It is geometry. It is the shape of space and time themselves. Picture a planet, not being yanked by an invisible hand, but simply following the curves of spacetime. Like a leaf drifting down a winding stream, it does not decide its own path. The river guides it effortlessly. In Einstein's world, planets are not held by the sun's pull. Instead, they are sliding along the grooves carved into the universe by the sun's mass. The sun, heavy and radiant, presses into spacetime, sculpting it like an artist pressing fingers into soft clay. Earth, obedient and free, traces those curves. Its orbit is not forced, it is natural motion on a curved stage. No ropes, no tethers, just the dance floor itself bending underfoot. And this view explains mysteries that Newton could not. Take Mercury, the tiny innermost planet, racing so close to the sun that it feels the full intensity of spacetime's warping. For centuries, astronomers noticed something odd. Mercury's orbit wobbled, its closest point to the sun drifting in a way Newton's equations couldn't predict. Einstein's theory of general relativity solved this puzzle effortlessly. His curved spacetime accounted for every fraction of Mercury's strange motion, as if a missing note in the cosmic score had finally been found. The universe wasn't broken. Our understanding simply wasn't complete. Now imagine this curved stage not as still but alive. Massive stars, black holes, galaxies, all sculpting, stretching, and sometimes even rippling spacetime itself. When two black holes collide, they send waves through this invisible fabric, like ripples on a still pond, traveling across the cosmos. Those ripples, gravitational waves, are whispers of the universe's deepest events, proof that spacetime is not rigid but supple, capable of vibration. In this soft geometry, you and I, Earth and Moon, planets and stars, are like dancers moving on a floor that subtly shifts beneath us. We never fall off. We simply follow its curves. Einstein once described this with beautiful simplicity. Matter tells spacetime how to curve, and spacetime tells matter how to move. It is not a command, but an invitation, a path written into the structure of reality itself. Close your eyes again. Picture the planets orbiting not in isolation, but on a vast, gently curved trampoline, gliding around the sun without ever needing a rope. Jupiter carves a deeper dip than Earth. The sun's hollow is deeper still, and if you could see it, not with eyes but with imagination, the solar system would look like a graceful sculpture, a pattern of curves etched into the invisible. This is not just physics. It is poetry written into the universe, where geometry becomes destiny and motion becomes music. Newton's clockwork has become Einstein's symphony. And yet, for you, here on Earth, nothing feels different. Apples still fall. The moon still circles. The sun still rises. But beneath that comforting predictability lies something far stranger. A cosmos that bends around every atom of mass, every drop of light. Even time itself flows differently depending on where you stand in this curved stage. Near massive stars or black holes, clocks run slower, as if the universe whispers, "Take your time. Gravity is strong here." Farther away, time hurries slightly. You do not notice, but the cosmos keeps this quiet rhythm everywhere. So, how do planets stay in orbit? Newton gave us a powerful first answer. A force pulling them in a balance with their speed. Einstein gave us a deeper one. There is no pull at all. They are simply walking along the natural curves of reality. This invisible stage, smooth, elastic, and endlessly vast, holds the entire solar system, the Milky Way, and every galaxy you can imagine. It holds you, too, right now as you lie still and listening, drifting on a planet that surfs these cosmic curves. Soon, we will travel to places stranger than our own solar system, where these rules are pushed to their limits. But for now, let yourself picture that great stage underfoot, space-time itself, and how the planets trace their paths not by effort, but by grace. The music of gravity does not stop at our sun. Far beyond the edge of our familiar solar symphony, other systems perform their own celestial dances, some harmonious, some wild, some so strange they defy imagination. Close your eyes and picture a planet hugging its star so tightly that its year lasts only a single Earth day. Picture another drifting so far out that one orbit takes centuries to complete. These are not distant fantasies but real worlds, found by astronomers with patient eyes and instruments sensitive enough to feel the tiny tug of unseen planets on their stars. Our own system gives us a preview of this richness. Around Jupiter whirl more than 90 moons, each tracing its own path in the giant's gravity. Some are locked in perfect rhythm, Io, Europa, and Ganymede in a three-note chord called resonance. Every time Io makes 4 trips around Jupiter, Europa makes 2, and Ganymede makes 1. Their gravitational pull on each other is a cosmic metronome, keeping time with unerring precision. It is gravity behaving like music, steady and predictable, yet beautiful enough to take your breath away. Move outward to Saturn, and you find not just moons but rings, vast, shimmering bands of ice and rock particles. From a distance, they seem solid and serene, but up close, they are rivers of billions of tiny worlds, each one in its own orbit. Collisions are rare, not because the particles stand still, but because gravity's geometry keeps them flowing smoothly, like dancers gliding past one another in perfect formation. Now drift beyond our sun out. There are planetary systems that make ours look almost ordinary. Some stars have giant planets that skim so close to their blazing surface that their atmospheres boil away. Others have small rocky planets tightly packed together, each chasing the other like runners on a crowded track. Astronomers have even found planets wandering free, not orbiting any star at all, cosmic nomads, drifting silently in the cold between suns. These distant systems remind us that gravity's dance can be orderly or chaotic. Planets sometimes migrate, slowly spiraling inward or outward as they trade momentum with disks of gas and dust. Some are thrown out entirely when a giant neighbor gives them a violent gravitational shove. Others settle into orbits so eccentric that they swing close to their star, then slingshot far into the dark before returning again. And yet, even in this seeming chaos, there is structure. Patterns emerge, like chords in a song you've never heard before. Resonances keep planets from colliding, much like Jupiter's moons keep each other in check. Even in systems utterly unlike ours, 2 suns with planets weaving figure-8 orbits, or worlds tilted sideways and spinning drunkenly, gravity still whispers its rules. Think for a moment about what this means. The way planets move is not a quirk of our solar system. It is a universal language, spoken across billions of stars. Whether the worlds are searing hot or frozen solid, whether they are rocky or gaseous, large or small, they obey the same cosmic grammar. They circle, they resonate, they migrate, they endure. And what about life? Could these distant orbits cradle oceans and skies, as ours does? Could creatures be gazing up at unfamiliar constellations, wondering how their worlds stay aloft? The answer is still hidden from us, but every new discovery hints that nature loves to build planets. And where there are enough planets, perhaps some will also host life. As you drift with me through these distant systems, let your thoughts soften. You don't need to remember every name or every detail. Just imagine the endless variety of worlds, each moving to the beat of its star, each guided by gravity's gentle hand. Some glide in perfect circles, some trace stretched ovals, some dance in steps so strange we've only just begun to understand them. All of them remind us of one simple truth. We are not alone in this cosmic choreography. Our Earth, circling the sun, is just one note in a grand, unending melody. And this brings us closer to home. Because if so many planets out there are stable enough to survive for billions of years, then our own orbit, steady and calm, is no accident. It is part of a deeper order, a harmony that stretches across the galaxy. Let this thought carry you like a lullaby. Across the universe, gravity hums the same song, and every planet, near or far, sings along. Now, let's return to our own small world in this moving symphony, to understand how Earth's orbit, our cradle, our home, sails through space like a silent ship. You return home now, at least to the place you call home, Earth, a small blue-green marble drifting in the great, black sea. After wandering among distant planets and foreign orbits, it's time to remember where you are, where you have always been, where, without noticing, you are still hurtling forward through the void. Earth traces an elliptical path around the sun, faithful and steady, at just the right distance to cradle oceans and forests, clouds and cities. But this perfect balance is not stillness. You are not anchored. You are moving, always moving, though you cannot feel it. Right now, you and everything you know are racing around the sun at nearly 30 kilometers every second. That's over 100,000 kilometers every hour. Faster than any jet, faster than any rocket humans have built. And yet it feels like nothing. The chair beneath you does not shake. The air does not scream past your ears. It feels as if you are resting, but you are gliding on an invisible track, guided by gravity's hand. And the sun itself, this great lamp in the sky, is also on a journey. It carries the Earth and the other planets with it as it orbits the Milky Way galaxy, completing a single cosmic circuit only once every 230 million years. The entire solar system is sailing through space like a ship with a glowing mast, crossing seas of darkness so vast that even light, the fastest traveler we know, takes hundreds of thousands of years to move between the stars around us. The galaxy, too, is not still. The Milky Way drifts, slowly and steadily, pulled by the gravity of unseen clusters, sliding toward its neighbor, the Andromeda Galaxy, on a path that will one day, long after Earth is gone, end in a slow, graceful collision. Even collisions in space can be peaceful when you think in millions of years. You live on a moving world, orbiting a moving star, inside a moving galaxy. There is no fixed point, no absolute up or down, no center to cling to, and yet there is balance. The same gravity that holds the moon near Earth and Earth near the sun holds our entire galaxy together in a vast, spiraling embrace. Imagine looking down at this motion from far above, not just at Earth orbiting the sun, but at the sun orbiting the galaxy sliding through a greater web of cosmic structure. From that distant view, it is all motion, all dance. Nothing is ever still. And yet here you are, safe, calm, breathing. Life is possible not in spite of this motion, but because of it. Earth's orbit keeps the climate steady enough for liquid water, the warmth of the sun balanced by the cold of space. The moon's presence stabilizes Earth's tilt, keeping the seasons gentle. Even the distant planets, Jupiter and Saturn, help shield us from wandering comets by tugging them away with their powerful gravity. The solar system works as a team, a quiet network of invisible forces that cradle our fragile world. It is easy to forget this. When you wake in the morning, you don't feel the ground beneath you streaking through space. When you look up at the night sky, the stars seem fixed, unmoving, like tiny holes punched in a black curtain. But they, too, are traveling, each star carrying its own planets, each world following its own path. The entire universe is alive with motion. Perhaps there's comfort in this thought. Motion does not always mean chaos. Orbits show us that motion can mean harmony, a balance of speed and gravity, of pull and push, of freedom and restraint. The planets do not fall into the sun because their forward motion keeps them ever on the edge of falling. Earth is always leaning toward the sun and always missing. That delicate miss is what keeps us alive. Now think of yourself again, not just as a passenger on Earth, but as part of this great journey. The atoms in your body were forged in stars that orbited other galactic centers long before the sun was born. You are older than this solar system. You are, in a very real sense, a child of cosmic motion, made from wandering stardust that has traveled far and wide to become you. As you drift towards sleep, imagine Earth's orbit as a cradle. Rocking you gently as it carries you around the sun, imagine the sun's path as a greater cradle, swaying through the galaxy. Motion upon motion, orbit within orbit, yet everything feels steady. Everything feels calm. You are not falling. You are flying, though the flight is so smooth you do not notice. The gravity that holds planets in orbit holds you, too, not by chaining you down, but by guiding you forward. And as this hour of reflection draws to a close, remember this. You live on a ship made of rock and air and water, sailing through infinite darkness with astonishing precision. You are safe. You are carried. You are part of the dance. Let that thought settle into your mind like a soft blanket. The universe is vast, but it is also home. As our journey comes to a close, let the image settle in your mind. Earth, our small and fragile home, sailing on an endless river of darkness, guided by forces we cannot see, yet can understand. Every orbit, every curve, every silent turn is part of a pattern written in the fabric of the cosmos. And somehow, here you are, breathing softly, alive on this moving world.